Good evening, children. Today we are going to discuss on this topic acidity of alcohol and phenol. Yesterday we had said that alcohols are acidic in nature, but at the same time we also have discussed that alcohols are much less acidic than water. Now coming to phenol. Phenol is acidic in nature. Acidity of phenol, it is much more than alcohol. So we can write very important thing. Phenols are more acidic than alcohol. So what is the reason? The conjugate base of phenol it is this one, which is called phenoxidine, and we see that phenoxidine is resonance stabilized. Phenoxidine is resonance stabilized. We can draw the resonance structure of phenoxidine. This lone pair will come here. This pi electron will come here. So one structure will be this. Another structure will be like this lone pair will fit here, and then this one will come over here. In this way, in the next structure, this one will go here, this one will continue. So this one will continue. So what we see is conjugate base of phenol, which is phenoxidine. It is resonance stabilized. This charge, negative charge, is spreading, nicely spreading. So phenoxidine is very stable. Phenoxidine is very stable. So we say that phenol is acidic in nature. Now if I compare acidity of phenol with alcohol, which is ROH, its conjugate base is RO minus, its conjugate base, and we see that because of Plaza effect, this conjugate base will be destabilized. So this alkoxide is not stable. So this is not acidic, not so acidic as compared to phenol. So we have discussed this point that phenols are more acidic than alcohol. In fact, phenols are much more acidic than alcohol. Now there is a term. pKa. You have to know there is a term called Ka. So what are these pK and Ka that you have to know? Let us consider a weak organic acid. You all know acetic acid is a weak organic acid. So it will ionize and equilibrium will be there. So this equilibrium is there, and the equilibrium constant, we can write Ka is equal to molar concentration of acidity This is called Ka. This is called acid dissociation constant, and greater Ka, greater is the acidity. Greater the value of Ka, greater is the acidity. So, if Ka values are given of weak acids, so from the Ka value we can make it out which one is stronger, which one is weaker. And the definition of pK is defined as minus log of Ka. pK is minus log of Ka, and the value comes out to be such that this thing happens. Higher Ka, then what happens is lower pK. So this thing follows. That means we can say if a weak acid is stronger, then it will have a higher Ka value, and correspondingly it will have lower pK value. So from the pK value we have to understand the acidity of substances. In exam, maybe acidity of phenol or alcohol or they may be quoted. They may be quoted with the help of pK value or K value. Generally, it is quoted with pK value. Okay. Anyway, now what is the effect of substituent on acidity of phenol? That we have to understand. Effect of substituent on acidity of phenol. Okay. So you see, if in phenol there is presence of electron withdrawing group. For one example of electron withdrawing group is say NO2 group. If NO2 group is present with the ring, then acidity of this compound is going to increase. Similarly, if there is an electron donating group in the ring, an example of electron donating group is say OCS3, then acidity is going to decrease. This is the electron donating group. This is the electron donating group. So their presence in the ring, there is a decrease in the acidity. So let us discuss this point. Suppose how can we explain this acidity order? Say suppose you are asked this question that this is paranitrophenol. Paranitrophenol is more acidic than phenol. Explain why. Paranitrophenol is more acidic than phenol. So we are going to write its conjugate base. So its conjugate base will be its conjugate base is this one, and it can be shown that this NO2 has minus R effect. This NO2 has minus R effect, and because of minus R effect, this negative charge will nicely get delocalized, and that's why this anion will be much more stable than phenoxide. So we can say that paranitrophenol is more acidic than phenol. So if I write this thing, para-nitrofenol is more acidic than phenol. And this will be more acidic than this compound. So why is the acidity ordered like this? Because it is an electron withdrawing group, and this one is an electron releasing group. So presence of electron withdrawing group leads to increase in acidity, and presence of electron donating group leads to decrease in acidity. Okay, now suppose if you are asked a question between these two compounds, this is metanitrophenol and this one is between metanitrophenol and para-nitrophenol, which one will be more acidic? Why this is a question? Because here also there is one NO2, here also is one NO2, just positions are different. And the answer to this question is para-nitrophenol, it is more acidic than orthonitrophenol. The answer to this question is how to explain this. You have to know that as I say here, this anion is getting stability by minus R effect, and you have to know that this minus R effect can operate from para position or from ortho position. This thing you have to know, minus R effect can operate only from para or ortho position. So here we have electron withdrawing group at meta position, so minus R effect will not be there. Here minus R effect will be there, it being at para position, so that's why this compound will be more acidic than this compound. Minus R effect will not take place, but of course there will be minus I effect here. There will be minus I effect, but minus I is always weaker than minus R. Okay, minus I is weaker than minus R, so that's why this compound is much more acidic. And we can put this one also here. Say this is more acidic than this one is more acidic than this one. This one is more acidic because there is some minus effect that will increase the acidity, but here there is no such electron withdrawing group. Okay, now so you see this order of acidity. Let's see here, nitro group, presence of nitro group makes it more acidic than this one. Nitro group at ortho makes it more acidic than this one because it is at meta. At ortho and para, it is minus R effect will be there. Here only minus I effect is there. And this thing you have to know that this is ortho and this is para. Why para one is more acidic? It is because in case of ortho, there will be a sort of intramolecular hydrogen bonding here. There will be intramolecular hydrogen bonding, and that will not help in the release of H+. that's why para-nitrophenol is more acidic than ortho 1. So I hope this order is clear. Now here you see another case. Here we have a electron releasing group or electron donating group. So here, since these groups will decrease the acidity, so phenol itself will be most acidic. Then it will be meta 1. Okay. Here then it will be para 1, and least acidic will be the ortho 1. Least acidic will be ortho 1 because it's very near, that's release will be more here than this one. Now in the end I would like to ask you this question. Suppose if we have in a phenol a substituent, say OCS3, presence of a methoxy group will increase the acidity or decrease the acidity. Why I am asking this question? Because you should know that O is more electronegative than carbon. So there is a minus I effect. There is a minus I effect, and minus I effect will increase the acidity. But at the same time, there is also plus R effect. Minus I effect is there. There is also plus R effect. Plus R effect means this lone pair it is in conjugation. So it is going into the ring. So there is also plus R effect. Now, so these are two opposite things, and now which one is more stronger? You have to know always. Resonance effect is stronger than inductive effect. So the net effect will be electron releasing. So methoxyphenol, that's why methoxyphenol will be less acidic than phenol. So this much for acidity of alcohol and phenol. You have to do in your exam. You have questions on arranging like this, so you have to prepare for it. This much for now. Thank you.